Hello and welcome to my channel. We are continuing our geometry interactive notebook flip through. We are now on the 6th unit, which is right triangles. This is my absolute favorite unit. This is the one unit that I've always taught. I taught it during the first maternity leave I ever took on for someone, during Algebra 1 as an introduction, and then I've just always taught geometry, so I've always taught this unit and I just love it so much. So I can't wait to share with you what we're doing. So this is the first time, I think, if I can remember correctly, that I'm able to actually use this year's current interactive notebook to show you the pages. However, all of the footage where I'm like doing the close-ups is going to be from the old notebook because I had that done and taken care of ahead of time. So the notes in here look a little bit different than they will on the close-ups because I shared in a previous video about how I'm using my iPad this year that I am putting all the notes into my iPad, annotating them on there, so that way every year I can print out the notes rather than have to handwrite them all over and over and over again. That's a lot of background information, but let's jump into this unit. There are 8 topics that we teach. We start out with Pythagorean theorem. So at this point, students have seen Pythagorean theorem since middle school. So they're familiar with it already. Most of them remember it. Some of them need the refresher. So we go over a squared plus b squared equals c squared. We go over the vocabulary that they need, like hypotenuse and leg, and just a right triangle, which they know, but it's just good to have the definition. Now in the examples, I have one that works out to be a radical, or it would be a decimal. And then I have one that works out to be a whole number. So I go into the difference with them and we talk about Pythagorean triples, and I have them listed out, the main 4 ones, the 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. And then I list some of the multiples and I explain all the stuff to students, and I encourage them to try to memorize them, because if they have them memorized, it helps on tests and with a lot of things. It just helps stuff go quicker. So they usually don't memorize them, but I love to make a bonus question on one of our quizzes list as many Pythagorean triples as you remember. But of course that quiz needs to be a closed notebook quiz. We have a couple of like practice test questions. We do the converse of the Pythagorean theorem, where they are determining if a triangle is a right triangle based on the sides when they plug into the formula. But that's everything for Pythagorean theorem. We come back to this topic so many times. We use it for so many things. So this is one of the more important topics that we teach, but luckily it's review. So we try to get practice in on their homework. I don't usually give them just practice on Pythagorean theorem. So after Pythagorean theorem, we go into the special right triangles. We talk about 45, 45, 90, and 30, 60, 90. So on the front cover, I give them all of the basic facts about how it works, and then on the inside under the flap I have how it happens, like why it's the sides are what they are for 45, 45, 90, and then we do the same thing for 30, 60, 90, where they basically are just deriving the side lengths using Pythagorean theorem, and then on the inside we have some examples. So we don't emphasize this too strongly in geometry. They need this topic more for Algebra 2. This is more like an introduction to it. It's not usually heavily tested, but I do talk to them about, you know, you'll see this in Algebra 2, you'll see it on the SAT, and if you go into pre-calculus, you'll see these again. And then we do the similar right triangles. So similar right triangles can also be part of the similarity unit. It's just based on your preference. I like to keep all of the right triangles together. So this is actually what we did today, altitude rule and leg rule. At least that's how we split it up. So I go over with them the triangles, how it's formed by having an altitude from the right angle to the hypotenuse, and how you have these 3 triangles and they're all similar to each other. And then I like to use the rules with the proportions set up for them, rather than have them try to figure out which sides are corresponding, because it's a little puzzle right here. So I show them the formulas, but then I've been using a method that was introduced to me by Miss Crafty Math Teacher, Kathleen Zita, on Instagram. I'll link her page below, but she explained one thing this one time and I was like, oh my gosh, yes, it makes it so much easier. So for the altitude rule, they call it a heartbeat. That when you go to set up your proportion, you have the one side of the hypotenuse, altitude, altitude again, and the other side. And then for the leg rule, she describes it as a boomerang, where you have the whole hypotenuse, the leg again, and then it comes back around to get the, what we call the projection, or that little piece of hypotenuse that touches the leg. So this was the lesson that we did today. It's a really short lesson overall because most of it's trying to explain how to set it up. And then we only have 4 examples because these diagrams take up so much space. So after my students fill in their notes, we do practice. I had one thing that I did a lot with like a sort and solve. So I had students sort 4 triangles into either being altitude rule or leg rule, and then solve for the missing side. And that's what I've done for years, and that would have been like its own page on here. But this year I decided just to do a Google form, because then they get more practice, because they can do a couple more problems rather than having to sort them and then solve them. Plus the Google form is self-grading. So I went with that this year. And then we get to trig. So this is going to be our lesson for tomorrow. Super excited. I love teaching this, like I said. So we go over the vocabulary for trig ratios, hypotenuse, opposite, adjacent, and then we define the 3 basic trig ratios. And then we have 2 examples where we are finding the ratios for sine, cosine, and tangent for 2 triangles, and we do it for both of the acute angles so that they could see some of the patterns that develop when they do. Then we'll do practice tomorrow. I have a sorting activity that also I have for the interactive notebook as well, but I like doing the digital activities because it, you know, conserves paper a little bit. So as I mentioned, I want my students to see the patterns on here because it makes our next lesson on cofunctions run a little bit more smoothly when we talk about how the sine of one angle is equal to the cosine of the other angle. And at that point, they've seen it on the table that we put together for the trig ratios. So then we do cofunctions. Now this is something that I never learned as a student, not directly, or at least not like this, but I love this topic. So we explain cofunctions, how they work, and then we do some practice problems. So I have 6 examples there that we work on together, and then I have a Google form or task cards. Like I said, I've just been doing the digital activities more frequently, but I do have like the physical task cards for this topic. So it's just great to practice because this is a topic that absolutely does show up on our test. I tell them this is a guaranteed question. Then we get to some other guaranteed questions. We have using trigonometry to find sides. So this is a booklet folded page. We just have the steps, and then we have 9 examples. So I do the first 3 examples with my students, and then I have them do the rest to practice. I like to break it up, and I have them do like the next 3, we go over them, then they do the next 3, and then we go over them again. And we repeat that when we go to solving angles the next time we have notes. So we have our steps, and then 9 examples, and again, we break it up. I have to make sure that I go over how to use the calculator with them, how to make sure it's in degree mode, because I also teach pre-calculus and calculus. So when they're doing trig stuff, they need it in radians. Luckily right now, all my geometry classes are on trig, so it'll probably just be in degree mode and stay that way for us. Now with finding sides and finding angles, we do a lot of practice. So it's at least 1 day for each. So after we do our notes on finding sides, I usually give them a worksheet where they're finding sides. And then we'll do our notes for finding angles, and then the next day will be a worksheet on finding angles. This year though, I think I'm doing my pixel puzzles for practice, and I will have the worksheet available for students if they want to show their work on paper rather than doing it on the marker board. So I'll give them a choice there. And then if my students need additional practice on this topic, I have lots of resources and all kinds of things that I've built up over the years from teaching this so many times. And then our last topic for this unit is applications. So we have a couple of word problems. We explain angle of elevation, angle of depression, and then we do our 2 examples, and then we do a whole bunch of practice. So we'll practice at least one day, the applications, but it could even be 2 because there are just so many questions from the state exams that I could go over with them, and they just do so many things differently and just so many different fun twists and different ways to do stuff. So I like to do lots of practice on this unit. And so that's everything for our right triangles unit. If you have questions about anything, please do not hesitate to ask, leave a comment, and as always, thanks for watching.